All right, so in this video, we're going to see an example of a linear subspace of a vector space. So let's just take a set U, and we're going to define the set as the following. So it's the set of all vectors in R3 such that 2 times the first coordinate plus 3 times the second coordinate plus the third coordinate equals 0. Now we're going to show that this subset is actually a linear subspace. So first, let's just get an idea of what this looks like. So some examples of vectors in U would be 1, -1, 1, because you can check that 2 times 1 plus 3 times -1 plus 1 is equal to 0. Another example of a vector in U would be 3, -2, 0. You don't have to actually find examples of vectors, but some cases it might help just to give you an idea of your subspace. Now, in order to check that it's actually a linear subspace of a vector space, it needs to satisfy 3 properties. We need to show that U is non-empty, that the sum of any 2 vectors is also in U. So if x and y are in U, then x plus y is in U. And we need to show that scalar multiples are in U. So if we have some vector x that's in U, then for any scalar, a times x is also in U. So let's check the first property. To show that it's non-empty, we already did this actually by giving you examples. So these would count as examples that confirm that it's non-empty. But an even easier example is just the 0 vector. Now to show that the sum remains in U. So let's take 2 vectors and assume they already belong in U. So let's take x and y with these coordinates and assume that they're already in U. So we want to show that their sum x plus y also belongs in U. Now x plus y has the coordinates x1, y1, x2 plus y2, and x3 plus y3, because when you add vectors, you just add the coordinates in R3. So what we need to check is that twice the first coordinate plus 3 times the second coordinate plus the third coordinate equals 0. We need to confirm this. So we'll start with what we know. We know that this expression plus this expression equals 0. And that's because x is a vector in U and y is a vector in U. So 2x1 plus 3x2 plus x3 is 0, and 2y1 plus 3y2 plus y3 is 0. So 0 plus 0, 0. Now I'm just going to break up the parentheses and rearrange some terms. So I rearrange the x1 and y1s, the x2 and y2s, and the x3s together, pull out the coefficients, and I'm left with my expression in this form. So this confirms that twice the first coordinate of x plus y plus 3 times the second coordinate plus the third coordinate equals 0. And finally, we need to show that scalar multiples are also in U. So let's take some vector x that's already in U, and let's confirm that the scalar multiple is also in U. So let's start with what we know. We know that 2x1 plus 3x2 plus x3 equals 0. Now if we multiply everything by a, we get that this equation still equals 0. And so now when I distribute out the a, I get 2ax1 plus 3ax2 plus ax3 equals 0. And so what that confirms is the vector ax1, ax2, ax3 is in U. And this is actually the same as the vector ax. So this shows the third property as well. So we showed all 3 properties for this to be a subspace or a linear subspace. And so we're done. So that's all for this video. If you thought this was useful, hit the like button and subscribe to this channel. Thanks for watching, guys.